4.2 Standard Form of a Quadratic Function. In this lesson, we're going to learn about the standard form for a quadratic function, which is different from the linear one that we've already learned about. We're going to find the vertex, find the axis of symmetry and the intercepts, discover if it's a maximum or minimum, and we're also going to, of course, talk about domain and range. So let's get started. All right, so the standard form for a quadratic function is f of x equals ax squared plus bx plus c, where a cannot be 0. Now this is different from your standard form for a linear equation, so don't get those confused. You can tell though, because the degree of this polynomial is a degree of 2, whereas the quadratic for a linear is the degree of 1. This term right here, the ax squared, is your quadratic term. The bx is your linear, and the c is your constant, or it's usually just a plain old number. All right, and we'll also be using the axis of symmetry. Well, that formula is x is equal to negative or opposite of b divided by 2 times a. All right, and we will get the b and the a from the standard form for the quadratic. We'll just take it straight from here. This will give us our x-coordinate when we find the vertex point. All right, when we find that x-coordinate, in order to find the y-coordinate of your vertex, you'll just plug in your x into the original equation. The vertex tells us the point where the maximum or minimum is located. It is like the very top of the mountain or the very bottom of the valley. That is where, before when we were working with vertex form, the HK. If the ax squared, or the quadratic term, is positive, it will have a minimum. It will be a smiley face, as you hear me talk about parabola. And if it's a negative, it will have a maximum or a frowny face parabola. Okay? So let's work one. All right, so the first one says find the vertex. That's the easiest way to start. So you're going to want to separate these into A, B, and C. Remember, our quadratic formula is, let's see if I've got it so you can read it. Our quadratic formula is f of x equal to ax squared plus bx plus c. So, looking at our equation right here, we have negative x squared plus 4x. So, our a term is negative 1, because remember, the 1 is really in front of that x. If there's not a number, it's really a 1, and this happens to be a negative, so it's a negative 1. Our b term, which is our linear term, is right here, and that is a 4. And our c is what? We don't have a c. It's like saying plus 0, so we're going to say 0. All right, then you're going to plug in to find your vertex. We're going to plug it in to find your axis of symmetry is the easiest route to go. So that formula is x is equal to opposite of b divided by 2a. So in this case, our b is 4, so that's going to be negative 4 divided by 2 times, what's our a? Negative 1. That ends up being x is equal to negative 4 divided by a negative 2 makes a positive 2. So x is going to be 2. So that's the x-coordinate of our vertex. Oops, go back. See, when I do that, it erases extra stuff. I don't know why, but it does. There's a negative right there. I don't know why it doesn't like our negatives when I erase something. Okay, so I now am going to look for my y-coordinate. I take this 2 and plug it into the original problem. So I'm going to write it over here. Negative 2 squared plus 4 times 2. Now notice I use parentheses for my x both times, because what is being squared is the x, not a negative x. It's x. If it was going to be a negative x, it would have to be in parentheses. So just know that if you have the situation, unless it's in parentheses, it's not a negative x, so that's being squared, it's just x. So this case, it's going to be 2 squared is 4, and then times a negative 1, it's going to make it a negative 4. So that's going to be negative 4 plus 8, which will make 4. So our y coordinate is 4. So our vertex is 2, 4. Our axis of symmetry is an invisible line. Okay, let's go ahead and plot our vertex here. 2, 4, right up here. 1, 2, 3, 4. That is the vertex of our parabola. And the axis of symmetry is going to be the x equals 2. We have already figured that out, so x is 2. Okay? Now, how to tell if it's a maximum or a minimum? Remember, if it is positive, it's going to be a minimum because it's going to be a happy, smiley parabola. And if it is a negative, it's reflected. Remember from our transformations, it's reflected and that's upside down. So that would have to mean it's a minimum. Okay? So that's a minimum. And that's going to be at y as 4. So once you have your vertex, you've just about got everything solved. This is going to be your axis of symmetry, and this is going to be your max or minimum on your y. Okay, so once you've got that done, you've just about got everything done. All right, so let's go ahead and find the domain and range and the y-intercept. Well, the y-intercept you want to do, plug in 0 for x and solve for y. Let's see, we're going to plug in for x and solve for y. So that means that it's going to have to be, we should just go ahead and graph this. All right, hold on. Let's just graph this. All right, so we've got a negative x. That's going to be going this way downward. All right. And again, this will be a U-shape, even though it kind of hard to make it look like a U-shape with us graphing the points this way, but it will eventually. Eventually, if we were to draw it really perfect, it would be a U. I will try my best. You know how my graphs go. Something of that nature. Okay? The axis of symmetry, again, is an imaginary line. Most of the time, you will see it with the dotted lines. So I'm drawing in the axis of symmetry. Axis of, I'm up on the axis of symmetry. What that means is, if you were to fold this parabola in half, it would be exactly the same on both sides if it was drawn accurately. Now, for any parabola, we've talked about this before, for any parabola, the domain will always be all reals. So let's talk about that. Let's put all reals. But often they'll have it written like this. So we need to make sure we know that it goes from negative infinity to positive infinity. That is another way of saying all reals. That means that it's going up all directions towards the negative infinity side. So let me write that in here. Negative infinity here and positive infinity here. That means it will incorporate every single x value. All right, and our range is the highest point that it's got, and that's at 4, and it's going to go downward. Okay, so the highest positive point is 4, so that would be a y is less than or equal to 4. Okay, it's not above 4, it's less than or equal to, and it goes on and on and on that direction. Okay, so then we would figure out, well, we've already figured out if the parabola will open up or down. This one will go down. And let's see, parabola y-intercept is going to be at, on this one, 0, 0. Y-intercept, of course, is where crosses y-axis. Okay? All right, so does it make sense? So once you have the vertex, and that's from plugging into your axis of symmetry formula right here. Okay, once you have that, you've got your x, you take that and put it back into your original equation and solve for y, and that'll give you your y coordinate. So once you have the vertex, that's going to be your axis of symmetry equation and your max or min equation, y equals. Okay, then you determine the domain and range. And again, with parabolas, they're always going to be all reals. And your range will be whatever your y value is, and depending on if it's going up or down, less than or greater than. And then your y-intercept is where it crosses the y-axis, and if it's open or going up or down depends on if the quadratic term right here is positive or negative. All right, and if you have any questions, come see me. We're going to do some practice problems in class. Until then, have a good night.